Yes, welcome to our channel of Sciences and Mathematics. We're going to look at one of the sample questions in our discussion that we had already done in the description for the gradient, divergence, and curls. And this sample question is going to assist us on how to tackle a question that we may come across that stems from the concept of a gradient, divergence, and curls. Now we have been asked to find del phi given phi is equals x squared y, the product of x squared y, or just a compound representation for x squared y z cubed, and a vector A is given as xzi minus y squared j plus 2x squared yk. Now in this particular case, we said that we can be able to represent this particular del phi by using the differential, the vector differential operator that we had referred to as the del that is given as this is dxi plus dy j plus zk. Now basically this one represents del, and this is given as del phi. So therefore we are going to do a substitution for that, but basically by merging this specific equation. So this is the first step. So step 2, we're going to just try to represent this phi in terms of I, j, k. So therefore it will be del phi dx I plus del phi dy j plus dz phi. This is okay. So basically this is how we can be able to represent this equation. Now from whatever we have been given for a representation for phi in this particular case, we're just going to do a substitution for this particular equivalent in this component for I, j, and k, and therefore we're going to have a resulting equation which is given as to minimize this space. My handwriting is big, so we have del phi given as e dx x, that is x squared y z cubed. Now that is going to represent the I components plus z, this is y, x squared y z cubed, this is for j, and then plus z x squared y z cubed. Okay, so basically this what this one implies. If we are having the first component for this one, that is for del phi, then we're going to differentiate this component for the part of x with respect to this particular representation. So therefore the other variables that occur for y and z, we're just going to maintain them the way they are. So therefore the del phi is going to be represented for the first one as a derivative for x component of that I part, which is going to be differentiating x, this one with respect to x, 2x, and we maintain the rest, which is y z cubed, and that is for I, and then plus, so the second one we're going to differentiate with respect to y, therefore it's going to be x squared z cubed j, the y disappear, and then plus the last one that is differentiating with respect to z, so we maintain others, this is going to be 3x squared y z squared. Okay, so basically that's how we're going to find this is del phi, which basically represents the gradient. So given an equation of this particular nature and a vector A and then we have been asked to find the gradient. We can use the above procedure in trying to find that specific gradient from that information that we have been given. So I hope that this is going to assist us, of course, in trying to figure out how we can work with the similar equations in trying to find our gradient. And of course, remember that this concept that we have mentioned for the gradient is a vector, and it can be represented as that. So this is it for now. We shall look at another one, which is a divergency, and basically curls in our next video. So for this, I hope that we have understood this one, and then we will apply it appropriately. So thanks. Bye. God bless.